Next problem says, in the network shown, the switch is closed at t is equal to 0. A steady state having previously been attained, find I of t. This is the switch. The switch is closed at t is equal to 0. So for t less than 0, the switch is open and the circuit will look like this, and you have I of t flowing here. So this is the circuit at t is equal to 0 minus, but steady state is reached, so you can find the current flowing through the inductor, which will be V upon R1 plus R2. Now for t is equal to 0 plus, the circuit will be the same, only instead of this you can draw a current source. So you can redraw the circuit at t is equal to 0 plus, have the voltage source, the resistor, and here you have the current source. So the current flowing is here, and you have the value as V upon R1 plus R2. This is R1, this is R2, and this is V. So I at 0 plus is again V by R1 plus R2. Then for t greater than 0, inductor will come and a current source, and at t is equal to 0 plus, this R2 will not come because the switch is closed. So you have a path in parallel to this, so this resistor will become redundant. So this will not there in at t is equal to 0 plus instant and after that. So KVL for t greater than 0, you will have this circuit, you will not have R2 because it is becoming redundant. So KVL for t greater than 0 we can apply in this loop. Here you have I of t, so V L di by dt plus R1 into I of t. This is R1 into I of t. Then getting in the regular form, di by dt plus R1 by L into I is equal to V by L. So we can say your Q and P from this equation. P is R1 by L and Q is V by L. You can write P is R1 by L and Q is V by L. So Q upon P will be V by L upon R1 by L. So you'll have V by R1 plus C e raised to minus Pt minus R1 by L into T. So you need to find C now. So at T is equal to 0 plus, I of 0 plus is V upon R1 plus R2. Then I'll substitute this in equation 1. So it will give me V by R1 plus R2 plus V by R1 plus C. So I can find C from this, minus V into R2 upon R1 into R1 plus R2. I'll substitute this 2 in 1. So it will give me I of t as V by R1 minus V R2 upon R1 into R1 plus R2 e raised to minus R1 by L into T, and after taking V by R1 common, we'll get 1 minus R2 upon R1 plus R2 e raised to minus R1 by L into T for t greater than 0. So don't forget to write the final condition for t greater than 0. This is valid, this equation is valid only for time t greater than 0. So this is how we can solve the problem.